All right, we are back. We also had a request to do Fall 19 Test 2 Part 1, and I'm looking for it, sorry. Part 1, the multiple choice with the titration curve. And I know it was done in the other section, but video might be helpful, so we're going to do it again. And I'm just working on this so you can see it. And we're getting over here. My computer's doing strange things, but that's okay. I'm used to it. And we're going to try to share the screen as soon as we can. All right, am I sharing the screen? I don't even know. Do we see?
Yeah, yes.
Question 19, good. And this is also Fall 19 T2 Part 1 this time.
Professor, after this
Yes.
problem, can we please do part 4, question 8?
Part 4, question 8 was the buffer one, right?
Yeah, the ice tables.
Yes, we'll do the ice table one next. Nice. That was also requested in a couple emails, so you're in good company. All right, now in a titration, you start in either one of two places. You start with the base form of something and titrate it with an acid, or you start with the acid form of a species and titrate it with a base. And if you're titrating the base form of a species, it should make sense the pH starts high, and as you add an acid, the pH goes down. The buffer regions in here, as you see, the pH isn't changing very much at all. That's what buffers do. And I just want to remind you, in this question, you start with all conjugate base. The generic for a conjugate base is A-, and the generic for acid is HA. The only important spot on the curve is where we have what's called an ideal buffer. And that's when you have 50-50 A- and HA concentrations, because pH will equal pKa when A- equals HA, all because of the Henderson-Hasselbalch equation. And we never have to use that as in a calculator. That is a very round square bracket, I apologize. But that proves that when these numbers equal, pH equals pKa, you don't ever have to prove it to me, just have to use it. So the titration took 12 milliliters of whatever acid was being added to get to completion. Halfway is the only part you are concerned about. Halfway is at 6. You got to read it up to the graph. That's not, I got to work on straight lines going vertical. 6 up to the graph. Oh, he's back. And then we got to say, okay, what was the pH when this thing was at halfway? And we read along there. And we see the pH equals 4.0. pH equals pKa equals 4.0. So automatically, you've got to use your pKa knowledge. The closest number to 4.0, HA, I don't need the square bracket. HA equals R. The closest one you've got is this. But you've got to wonder why Dr. Whitaker didn't have 5.0 here if he wanted us to have a carboxylic acid be the acid coming from a carboxylate, which would be the base, the conjugate base. Why did he put 4.0? Well, it's because he wanted to make sure that we studied what's called the inductive effect. R must have an inductive effect, because that's something that will lower the pKa, and that's an R, not an E. And it looks less like an R than it did before. There we go. Inductive effect. And that's when an electronegative atom draws electrons towards itself, thus stabilizing RCO2 minus. That means it's easier to make RCO2 minus if R has an electronegative atom in it, which will make this a stronger acid. All I'm trying to say is RCO2H fits best, not this one, but this one. The one where there's an inductive effect of the fluorine attached to the R. Here the R is CH2 with a fluorine in it. Here the R is a CH3. And neither one of these is the answer, by the way, because we're not asking about the acid in this. We're asking about the base being titrated. Okay? So the one with the inductive effect that's the conjugate base of this is this answer right here. Right here. I don't know what it's going to do with that circle. It left it. Thanks. Okay. So that is our answer. We're going to save that. And we have a video of the other section where we did a more straightforward titration, where we started with the acid. So you didn't have to do that step at the end, saying we predicted the acid here. The answer is the conjugate base. In the other section, the acid you found was the right acid right from the beginning, because you started low and ended high. Look at that video. And I hope that was helpful. And I'll wait a second for any questions. Otherwise, I'll come back and we'll do the thing we discussed earlier with the ice problem. Fair enough? Fair enough. All right. We'll come back. I'll have the ice problem set up. Probably take 2 minutes.